Section 2.1, Objective 1, determine whether a number is a solution of an equation. Definition. All right, we're going to start off with the definition of a linear equation. A linear equation in one variable is an equation that can be written in the form ax plus b equals c, where a, b, and c are real numbers and a is not equal to 0. All right, some examples of linear equations in one variables would be 3x plus 5 equals 25, and 4/7 equals 8a. These are examples of linear equations. The 3x plus 5, we would call this the left side of the equation. And the 25, we would call this the right side of the equation. So here, if you notice, the expressions are called the sides of the equation. So right here, the 4/7 and the 8a, those are the sides. One side's called the left side, and then the other side we can call that the right side. Equations are statements that can either be true or false. Our goal is to find those values of the variables that make the equation a true statement, meaning that when we substitute those values of the variable into the equation, the quantity on the left side will be the same quantity that is on the right side of the equation. Definition. The solution of a linear equation is the value or values of the variable that make the equation a true statement. The set of all solutions of an equation is called the solution set. The solution satisfies the equation. Okay, let's go ahead and do an example for this. Determine if x equal to -1 is a solution to the equation -3 times the quantity x minus 3 equal to -4x plus 3 minus 5x. So what we're going to do here is we are going to substitute x equal to -1 into this equation. Every time we see an x value, we're going to write -1 instead. So there'll be a -1 here, a -1 here, and a -1 here. Everything else in the equation is going to stay the same. Okay, now let's see if this comes out true or false. In here, -1 minus 3, that's going to give me -4. And we don't know if this is true, so I should probably put like a little question mark here, because I'm not sure if this is going to come out true or false yet. -4 times -3, I'm sorry, -4 times -1 is +4. And -5 times -1 is going to give me +5. Over here, we're going to end up with a +12. And over here, we're going to have 4 plus 3, that's going to give me 7. And 7 plus 5 is going to give me 12. And this ends up being true. Therefore, this x equal to -1 is a solution. So our final answer here would be yes. Yes being the key part here. Yes, x equal to -1 is a solution. If the value of the expression of the left is the same as the value of the expression on the right, then x equal to -1 is a solution. If the values had been different, then this would have been false, and then it would have not been a solution. For example, if we had said, if we had asked, let's pretend that we asked, is x equal to 5 a solution? Well, if you actually work this out, and you guys should go through the process of working it out, you're going to see that the left side is going to equal -6 and the right side is going to equal -42. And since -6 is not equal to -42, x equal to -5 is not a solution. So this would be no. This is not a solution. But you should work that out on your own, okay? Section 2.1, Objective 2, use the addition property of equality to solve linear equations. Linear equations are solved by writing a series of steps that result in the equation x equals a number. So when you get to that point, when you got x equals a single number, you know you've solved the equation. One method for solving equations is to write a series of equivalent equations. All right. And one way we can do that is by using the addition property of equality. The addition property of equality basically allows us to add the same number to both sides of an equation. The property states, the addition property of equality states that for real numbers a, b, and c, if a is equal to b, then a plus c is equal to b plus c. In other words, whatever you add to one side of the equation you must also add to the other side of the equation. Okay? Now I know you're thinking addition, that means we can only add the same thing to both sides, but remember that we can also do this with subtraction. When we have subtraction, for example, a minus b, this is equivalent to a plus a negative b. So subtraction can also be thought of as addition. Adding a negative number is the same thing as subtracting a number. So we can, when you hear the addition property of equality, don't think that that just means adding the same number to both sides of the equation. You can also think of it as subtracting the same number to both sides of an equation. All right, for example, consider the equation 6 plus y equals 11. And in this particular equation, what we want to do is we want to find the value for y. In order to isolate the y, we would need to get rid of the 6 that's being added to the y. So the opposite of adding 6 is subtracting 6. So I can subtract 6 to both sides of this equation. 6 minus 6, that's just going to cancel out, or it's just going to give me a 0. And then I'll be left with y is equal to 5. Okay? And we're going to get used to writing this as a solution set. Like this. Okay? Our goal in solving any linear equation is to get the variable by itself. With the coefficient of 1. By the way, when you solve any kind of equation, it is in your best interest to always, always, always check your answer. So if I wanted to check this particular answer, the one that I just finished doing right here, right over here, check. I had 6 plus y is equal to 11, but instead of y, we're going to substitute 5 for y. So this will give me 6 plus 5, and we're going to check to see if that's equal to 11. 6 plus 5 is equal to 11. Therefore, yes, 5 is the solution to this equation. Okay, let's go ahead and do an example. Solve the linear equation x minus 9 equals 22. Let me rewrite this equation right here. In order to isolate the x, or get the x by itself, I need to undo what's being done to it. If I'm subtracting 9 to the x, I need to do the opposite of subtracting 9. I need to add 9, and I need to add it to both sides of the equation. Negative 9 plus 9, that's going to cancel out and just give me a 0. So I'll be left with x is equal to 22 plus 9, which is 31. So my solution is going to be 31. Now we should always check it to make sure that we didn't make any mistakes. So let's do the check over here. Check x minus 9. We always go back into the original equation and we substitute for our x into the original equation. So this will be 31 minus 9, and we're going to see if that's actually equal to 22. 31 minus 9 is equal to 22, therefore 22 is equal to 22, therefore we have a true statement. This means that 31 is our solution. Notice that when we write a solution, we use braces for our solution set. Let's do another example. Let's solve the linear equation n plus 4/3 is equal to 6/5. So I want to isolate the n. That means I need to figure out what's being done to the n. I'm adding 4/3 to the n. The opposite of adding 4/3 is subtracting 4/3. So I'm going to subtract 4/3 from both sides of the equation. 4/3 minus 4/3 is just going to give me a 0, so we'll be left here with n is equal to, in order for me to subtract these two fractions, I'm going to need a common denominator. So the least common denominator here is going to be 15. So I'm going to have to we're going to multiply the top fraction by 3 to the numerator and denominator, and the bottom fraction by 5 to the numerator and denominator, which will result in 18/15 minus 20/15. So my solution is going to be -2/15, and I'm going to write that as a solution set. Just to be on the safe side, we should always check our work. Make sure that this is the correct answer. So we're going to go back for n, and we're going to substitute -2/15 for n. And now we're going to add 4/3 to that and see if that's actually equivalent to 6/5. I'm going to need a common denominator here, so I need to multiply by 5 to the numerator and denominator here of the 4/3. So that's going to give me -2/15 plus 20/15. And we're trying to see if this is equal to 6/5. -2/15 plus 20/15 is 18/15. Well, 18 is the same thing as 2 times 9. And 9 is the same thing as 3 times 3. And 15 is the same thing as 3 times 5. So it looks here we're going to have a common factor that we can cancel out both in the numerator and denominator. I can cancel out a common factor of 3, and that's going to leave me with 2 times 3 is 6 over 5. 6/5 is equal to 6/5. So yes, that means that -2/15 is the solution set to this equation. Section 2.1, Objective 3. Use the multiplication property of equality to solve linear equations. Multiplication property of equality. The multiplication property of equality states that for real numbers a, b, and c, where c is not equal to 0, if a is equal to b, then a times c is equal to b times c. In other words, whatever you multiply one side of an equation by, you must also multiply the other side of the equation by as well. For example, consider the equation 1/7 x is equal to 4. Here we need to find the value of x. In order to find the value of x, we would need to multiply by the reciprocal of 1/7 to both sides. The reciprocal of 1/7 would be 7, or 7 over 1. So this is going to give me 7 over 7. X is equal to 4 times 7, which is 28. 7 over 7 is just 1x. So we achieved that coefficient of 1 that we wanted in front of our x. And we have now x is equal to 28. So our solution would be 28. Remember, our goal is to get the x by itself with a coefficient of 1. So this is our coefficient of 1. All right, let's do another example. Solve the linear equation (3x is equal to 81). So just like we mentioned before with the addition property of equality, that we don't just add to both sides of the equation, but we can also subtract to both sides. The same thing occurs here. We don't just have to multiply both sides, we can also divide, because when you are multiplying, say when you're multiplying 3 over 1 by 1/3, this is equal to 3 divided by 3. So we can also think of division in terms of multiplication. So in this case, 3x is equal to 81. We can think of it in two ways. We can think of it as multiplying by 1/3, right? The reciprocal of 3. Or we can divide both sides by 3, which is also considered the inverse operation that we're doing to the x. 3 times x, the opposite of multiplying x by 3, it would be dividing by 3. 3 divided by 3 fits one time. So we get 1x is equal to 81 divided by 3. This is 27. So our solution set for this problem would be 27. Now you're not done until you check your solution. So don't be lazy. Check it. So 3 times 27, and we're trying to see if this is equal to 81. 3 times 27 is 81. Therefore, this is true. So 27 is our solution to this equation. All right, good. Let's try another problem. Solve the linear equation -6z is equal to 15. So once again here, z is being multiplied by a -6, but we want to get a coefficient of +1 in front of the z. So I'm going to do the opposite or the inverse operation. I'm going to divide both sides by -6. -6 divided by -6, that's just going to give me a 1. So we'll just end up with 1z is equal to 15 over -6. This can be reduced. The prime factorization of 15 is 3 times 5, and the prime factorization of 6 is 2 times 3. So we can cancel out a common factor of 3. So we will be left with -5 over 2. Remember that negative, you can write it on the top, you can write it in front of the fraction bar, or you can write it on the bottom, the front of the denominator. So whether you put the negative in the numerator, in the denominator, or in front of the fraction bar, it all represents the same answer. And you're not done until you check this solution. So let's go ahead and check it to make sure that this is actually the correct solution here. Why don't I go ahead and I just take this and I just move it on over here. So that'll give me a little bit more space on this side to do the check. So this is going to be -6, and I'm going to multiply. Instead of z, I'm going to write -5 over 2. So I'm going to write a 1 under the 6, so that way it reminds me what I have in the denominator there. -6 times -5 is going to give me +30, and 1 times 2 is 2. 30 divided by 2 is 15. 15 is equal to 15 is a true statement, so yes, -5/2 is my solution for this particular equation. Let's do one more example. Solve the linear equation -10 thirds is equal to -5/6k. All right, we're trying to isolate the variable, which is the k. Since we are multiplying k by -5/6, I need to multiply by the reciprocal of 5/6. Let me rewrite the equation. The reciprocal of -5/6 would be -6/5. And I'm going to multiply that to the other side of the equation as well. So this will give me -6 times -10 is +60. 5 times 3 is 15. -6 times -5, that's going to give me +30. And then 5 times 6 is +30, which is going to just give me a 1. So this will give me 4 is equal to 1k, or just k. So my solution here would be 4. Let's check that and make sure we have the correct answer. I'm going to substitute 4 in place of k, and this is going to give me -5 times 4 is -20. 6 times 1 is 6. And if I factor that out, the prime factorization of 20 is going to be negative here. 2 times 2 times 5 over prime factorization of 6 is just 2 times 3. So we can cancel out common factor of 2. And here we'll be left with 2 times 5 in the numerator, which is 10. Don't forget the negative. And then we've got 3 in the denominator. So we're going to end up here with -5 10 thirds is equal to negative 10 thirds. Yes, it's true. Therefore, the solution to this equation is going to be